Hello class, in this video we shall be discussing about the methods for expressing the concentration of a solution. So we can represent the concentration or the units of concentration in the following different ways. The first one is a mass percentage, or also it can be represented in the form of volume percentage. Second one is a parts per million. Okay. Third one, molarity of a solution, molality of a solution, mole fraction, normality and formality. Okay, so let us see one by one. Let us see the first one, that is mass percentage or volume percentage. Okay, so mass percentage of a component in a given solution is the mass of the component per 100 gram of the solution, which is given by mass percentage of a component. Again, mass percentage of the component, okay, will be equal to mass of the component in solution divided by total mass of the solution. Okay, the total mass of the solution multiplied by 100. So that way we find out the concentration in terms of mass percentage. Okay, if suppose two components are there in a mixture or solution, okay, A and B, and we are asked to find out the mass percentage of A. Okay, so their respective masses are WA and WB. So what we do is, like, mass percentage of A will be equal to mass of A, component A, divided by mass of component A plus mass of component B, which will be multiplied by 100. Okay, so that way we find out the mass percentage, okay, for any component in the solution. Now in that same case, the volume percentage also will be similar. Okay, so it says that volume percentage is defined as the volume of component per 100 parts by volume of the solution. So which is given by, so I shall just change it here. Let us see here. Suppose two components A and B having volume VA and VB. Okay, VA and VB. So volume percentage of, say, component A will be volume of A divided by volume of A plus volume of B multiplied by 100. So that is how we find out the volume percentage for any component in the given solution. Okay, the next one is parts per million. Okay, it is abbreviated as ppm. Okay, now this parts per million is the parts of a component per million parts of the solution. So this one is used when the solutes are present in a very small amount. Okay, in a very small amount, so that time we use this parts per million. So suppose we are asked to find out the parts per million of component A. Okay, then we write parts per million of component A will be equal to mass of component A divided by total mass of solution and multiplied by 10 to the power 6. So million is 10 to the power 6. Okay, and that way we find out the value for any given components in a solution. Okay, and we shall write the unit as ppm. Okay, let us try one numerical problem. Okay, in order to calculate the mass percentage. Okay, so on the board, if 11 gram of oxalic acid are dissolved in 500 ml of solution, given density is 1.1 gram per milliliter. This density is of the solution. Okay, what is the mass percentage of oxalic acid in solution? So see, this is the 11 gram oxalic acid. Okay, and this oxalic acid is dissolved in a solution containing 500 ml. Okay, and this is the density of the solution. So given, okay, density of solution equals to 1.1 gram milliliter inverse 1. Okay, we know density formula is mass by volume. Okay, so if it is density of solution, it will be mass of solution by volume of solution. Okay, so mass of solution divided by volume of solution, okay, which will be equal to 1.1 gram milliliter inverse 1. Then mass of solution will be equal to, we cross multiply with these two, that is 1.1 gram milliliter inverse 1. Now the volume of the solution is given 500 ml, so I put 500 ml. Okay, then mass of solution will be equal to, this one we get around 550. It will be this ml minus 1 and ml gets cancelled, so it will become 550 gram. Okay, so the mass of the solution is 500 gram. Then next one, we're asked to find out the mass percentage of oxalic acid, and mass of oxalic acid is 11 gram. Okay, so mass percentage of oxalic acid will be, mass percentage of oxalic acid will be mass of oxalic acid divided by total mass of solution, which will be multiplied by 100. Okay, so it is 550. Okay, the mass of the solution. Mass of oxalic acid we know it is 111, and the mass of the solution was 550 gram. Okay, so gram and multiplied by 100. Okay, so what we get is, after you calculate this one, okay, it will come around 2%. Okay, so this is the required final answer. The third one is the molarity of a solution. Okay, so it is the number of moles of the solute dissolved per liter of the solution. Okay, so molarity is represented by capital M. Okay, now we represent mathematically like this, that is molarity, okay, equals to number of moles of solute divided by volume of solution multiplied by 1000 if, okay, this one it will be if volume, okay, if this one is in milliliter. Okay, I'm writing here if this one is in milliliter. Then the another one is molarity is equal to number of moles of solute, okay, you can write or, okay, divided by volume of solution in liter. Okay, in liter it will be, okay, we won't multiply by 1000. Okay, now here as you can see, the unit for these two will be, the unit of this one is also mole per liter, this also will be mole per liter, or we can also just write capital M instead of mole per liter, we can also write capital M, or here also capital M. Okay, so that is how we represent the unit. Okay, now in order to find out the number of moles of solute, okay, so number of moles of solute will be given mass, okay, mass of solute divided by molar mass of solute. So that is how we can find out the number of moles of solute. Okay. The fourth one is the molality of a solution. Okay, so it is the number of moles of the solute dissolved per 1000 gram or 1 kg of the solvent. It is denoted by small letter m. Okay, and it is represented as, okay, molality or small letter m is given by number of moles of solute or just moles of solute, okay, of solute divided by mass of solvent. Okay, if it is in kg, we don't multiply by 1000, or molality m equals to number of moles of solute divided by mass of solvent in gram. Okay, if it is gram, then we multiply by 1000. So here the unit, okay, in both cases it will be mole per kg. Here also mole per kg, or we can also write small m. Here also we can write as small m. That is the molal. Okay. The fifth one is the mole fraction. Okay, it is the ratio of number of moles of one component to the total number of moles, that is of solute and solvent present in the solution. Okay, so suppose we are asked to find out the mole fraction of a component, then it will be equal to, okay, number of moles of the component divided by total number of, okay, total number of moles of all component. Okay, so that is how we find out the mole fraction of a component. Suppose let us take A as solute and B as solvent. Okay, and say the number of moles of component A, B and A, the number of moles of component B, E, B and B. Then the mole fraction, okay, mole fraction of component A, which is written as XA, it will be equal to number of moles of that component. So here this is, if it is of component A, then it will be A divided by total number of components. So here in this mixture there are total 2 components, therefore it will be Na plus Nb. So this is how we find out the mole fraction of component A, written as Xa. Okay, if we are asked to find out the mole fraction of component B, then it will be mole fraction of component B, that is mole fraction of component B, written as Xb, which will be equal to Nb by Na plus Nb. Okay, now remember, okay, the sum of these two mole fraction, that is Xa plus Xb, will always be unity. Okay, and if it is more than 1, that means the answer is not right. Okay, the sixth one is the normality. Okay, it is the number of gram equivalents of the solute dissolved per liter of the solution. So this is denoted by capital N. Okay, so normality, okay, N is given by, Okay, number of gram equivalents of solute, number of gram equivalent of solute divided by volume of solution. Okay, and if it is in liter, we don't multiply by 1000. Okay, or it can also be in milliliter. Okay, we can write normality n equals to number of gram equivalent, okay, of solute divided by volume of solution in ml. Okay, here also you can write in ml, in liter. Then if it is in ml, we multiply it by 1000. Okay, now let us see what is this number of gram equivalent of solute. Okay, so gram equivalent of solute is gram equivalent of solute equals to, okay, mass of the solute, okay, mass of solute by equivalent mass. Okay, so mass of solute will be that given mass. Okay, now what is equivalent mass? Let us see. Equivalent mass is equal to molar mass divided by, say, suppose valency. Okay, it can also be as acidity, basicity. Okay, so those things. Say for example, we have to find out the equivalent mass for oxalic acid, COOH, COOH. Okay, so the molar mass of this one, okay, you find out. Okay, and the valency or acidity will be then how many hydrogens can be lost from this acid. It can lose 2 hydrogen. Okay, so that's why the valency or acidity will be 2. Okay, and that molar mass you put here, you solve it, and that will be your equivalent mass. Okay, the seventh one is the formality. Okay, it is the number of formula masses of the solute dissolved per liter of the solution. So this is represented by capital F. Okay, so formality, okay, formality F equals to number of formula mass of solute, number of formula mass of solute divided by volume of solution. Okay, volume of solution in liter. Okay, now this formality is one that is very least used. Okay, so in our next video we shall try to solve some more numerical problems related to these things. Okay.